Hello and welcome you all. Today in this video we will be doing some more questions based on properties of determinant. So our first question for today is prove that determinant b plus c, a minus b, a, c plus a, b minus c, b, a plus b, c minus a, c is equal to 3abc minus a cube minus b cube minus c cube. So to prove it, as I have already told you, at first you will add all the elements of either row R1, R2, R3 or column 1, column 2, column 3. And if the elements are found to be same, then your operation is correct. So here, when we add all the elements of row R1 by applying the operation R1 tends to R1 plus R2 plus R3. So the first element of row R1 will become B plus C plus A plus B, which is equal to 2A plus 2B plus 2C. So from here 2 is taken as common and in bracket we get A plus B plus C. And now second element of row R1 will be equal to A minus B plus B minus C plus C minus A. So from here A and minus A will get cancelled out, minus B and plus B will also get cancelled out, and minus C and C is also get cancelled out. So from here we get 0. So from here second element of row R1 is 0. And the third element of row R1 will become A plus B plus C. And the rest elements will remain as it is. And now when we take A plus B plus C common from row R1, we get in our determinant 201 C plus A, B minus C, B, A plus B, C minus A, C. And now applying the column operation, that is C1 tends to C1 minus twice of C3. So from here we get A plus B plus C, and in determinant as the elements of column C2 and column C3 will remain unaffected. So write them as it is. And the first element of column C1 will become 2 minus 2 into 1. So 2 minus 2 is 0. And then C plus A minus 2 into B. So from here the second element of column C1 will become C plus A minus 2B. And the third element of column C1, which is A plus B, and then minus of 2 into C. So from here we get A plus B minus 2C. And now using the operation C1 tends to C1 plus C2. As from this operation the elements of C2 and C3 will remain unaffected. So write them as it is. And elements of C1 will become 0 plus 0. So 0, and then C plus A minus 2B plus B minus C. So from here C and minus C will get cancelled out and we get A minus B. And third element of column C1 will become A plus B minus 2C plus C minus A. So from here A and minus A will get cancelled out and we get B minus C. And now on expanding it along row R1, we get A plus B plus C, and in bracket A minus B into C minus A, and then minus of B minus C into B minus C, which is equal to B minus C whole square. So on solving it, we get A plus B plus C, and in bracket A into C, AC, and then minus A square, and then minus of BC, and minus B into minus A is plus AB. And now when we expand B minus C whole square, we get minus B square minus C square and plus of BC. So from here we get A plus B plus C, and in bracket minus A square minus B square plus AB plus BC and plus AC. So when we take negative common from here, we get A plus B plus C, and in bracket A square plus B square plus C square minus AB minus BC minus CA. And from here using the algebraic identity which we have studied in class 9th, that is A cube plus B cube plus C cube minus 3ABC will be equal to A plus B plus C, and in bracket A square plus B square plus C square minus AB minus BC minus CA. So in place of A plus B plus C and A square plus B square plus C square minus AB minus BC minus CA, I can write minus of A cube plus B cube plus C cube minus of 3ABC. And now on multiplying it by negative, we get 3ABC minus A cube minus B cube minus C cube, which is equal to our RHS. So hence proved. And now our second question for today is prove that x plus y, xx, 5x plus 4y, 4x, 2x, 10x plus 8y, 8x, 3x is equal to x cube. So from here, as you can see that the elements of column C1 is the sum of two terms. So I can write it as sum of two determinants, in which one determinant containing only the first term and the other determinant will contain only the second term. Also the remaining elements of both the determinants will remain same. So I can write it as x, xx, 5x, 4x, 2x, 10x, 8x, 3x, and then plus y, xx, 4y, 4x, 2x, 8y, 8x, 3x. So from our first determinant, we take x common from row R1, row R2, and row R3. So our determinant will be equal to x cube, and in determinant we get 111, 542, 1083 plus, and similarly from other determinant, when we take y common from column C1 and x common from column C2 and C3. So here we get yx square, and in determinant 111, 442 and 883. So in this determinant, as you can see that the elements of column C1 and column C2, they are identical. So therefore its determinant is equal to 0. Therefore our determinant will be equal to x cube, and in determinant 111, 542, 1083. And now we have three ones. So here we will apply column operation, that C1 tends to C1 minus C3 and C2 tends to C2 minus C3. So by this operation, the elements of C3 will remain as it is. And when we apply the operation C1 tends to C1 minus C3, the elements of column C1 will become 1 minus 1, 0, and then 5 minus 2, which is equal to 3, and then 10 minus 3, which is equal to 7. And now the elements of column C2 will be equal to 1 minus 1 will be equal to 1, and then 4 minus 2, which is equal to 2, and then 8 minus 3, which is equal to 5. So now when we expand it along row R1, we get determinant is equal to x cube into 1, and in bracket 5 3s are 15, and then minus 7 2s are 14. So from here our determinant is equal to x cube, which is equal to RHS. So hence proved. And now practice this question, mention on your screen and submit me the solution. So thank you so much. This is the end of this video. Have a great day ahead.